Increasingly popular among engineering students and lecturers at tertiary institutions across the southern African continent, interest in the Siemens CyberJunkyard competition is at an all-time high, thanks to, amongst others, the equipment worth millions of rands on offer to participating teams, as well as the exposure to practical, real-world applications. Devendree Karuppannan, CyberJunkyard project manager at Siemens Automation and Drives, is here to talk to us about what went down this year at the competition. Welcome.
Do you want me to tell you a bit about the competition?
Yeah, by all means, go for it, yeah.
Basically, it was born out of a need to forge closer ties with the universities and technicons. And on our side, what we're basically doing is giving them a real-life application, much smaller scale, however, and then the equipment and training to actually build whatever we're asking of them. Each year, the concept changes, and we have two basic criteria on how we change the look at what concept comes up. One, what does industry need at the moment? So this year's concept was energy efficiency, which I'm sure you all agree is big needs in South Africa.
Yeah, absolutely. We've had enough power failures on our side of the world too.
So, you know, we're basically singing the same song as Eskom. If you can do stuff more efficiently, your electrical usage is down. For Eskom, well, it helps them with demand-side management. For you personally, it helps you on your costs and all of those other good things.
Now tell us a bit more about, before we get into the efficient energy part, what are some of the other concepts that you've had in the past?
Okay, I think in the first year we had a pick-and-place anti-crane application. Then we had a bottling application, keyring manufacturer. Each year it changes, and like I told you, we sort of try to see what's happening in industry at the time. And we even did warehouse applications. All these were nice to do things. And then this year we sort of changed the focus a little bit and we looked, what does industry need at the moment? So each year, the concept sort of changing and trying to meet industry needs, if you like.
Now, let's talk about, I mean, some of the stuff. I'm an engineering student. I've now applied for this for this competition, and it's a very limited number that you choose. Yes. It's not sort of everyone and their grandmother that can compete in this.
Initially, whoever was interested, we were giving places to, but then the interest has grown so much because of what's on offer, personally to the students and the universities, that we had to now put limits on who gets in. So what I do is we send out a tender. Any big project in industry, you have to tender to participate. And what we have done is we give you a tender with the specifications and tell you exactly what you're supposed to build. Then you respond. And based on that response, we choose the top 10 South African institutions. And in the SADC countries at the moment, we're just doing one per SADC country. And we're hoping that the SADC involvement would increase. At the moment, we just had 3 countries that were participating this year.
Now, essentially, it's up to the students then to do their research and find out. Because I know with the crane example that you mentioned, I think the winning team came up with something that would stabilize. I mean, something that nobody, I would have never thought of, stabilizes the container over the ship that normally takes a couple of minutes or hours or whatever to do. They've invented something that stopped the thing wobbling.
They actually came up with the anti-sway algorithm, which was...
Sorry, what?
Anti-sway algorithm.
Anti-sway algorithm. That's what I was going to say, yeah. Okay. Nice.
And now the bigger crane companies have now caught on to this idea and now want to purchase it and sort of implement it in industry.
Now, obviously this is something quite small in comparison to the rest of it. And I mean, how much does an idea like that worth?
A lot. To be quite honest, I don't know the actual monetary value associated to these things, but I'm quite sure it's a lot because they would roll it out to all their crane applications throughout the world. To give you an idea, what we're actually doing is, why we actually also limit who gets in is because we know South Africans are bright. Not just South Africans, everybody in the Southern Hemisphere. And we're giving them the opportunity to use this talent, you know, to in the judging criteria, 25% is innovation. We're saying that, you know, guys, we know that you have brilliant ideas. We're giving you the opportunity to implement it. We do have design considerations that have to be met because you have to understand, in real world, your customer is king and you have to deliver what your customer requires. And to the universities, it's like we're the customer. We've given you a specification that you have to meet, but of course, we're giving you 25%. Go wild, come up with bright ideas.
Now let's look at the energy efficiency concept that you guys have sort of put forward this year. Yep. What are we looking at? Are we looking at sort of, I mean, better solar panels? Are we looking at a better way to, you know, distribute electricity?
It's not so straightforward. For starters, it's too early for us to tell you exactly what's happened. The competition was not even 24 hours ago, the finals. And we had so many brilliant ideas that the directors at Siemens actually told us we need to have a follow-up on this and go through each project and what these students have come up with. Because even, to give you an example, normally the top 3 is very easy to judge. But this year, 10 of the institutions that participated deserve to be in that top 3, but of course we can only choose 3, first, second and third. And what we're going to do now is we're going to go back, go through these projects, what they've come up with, get engineers at Siemens to have a better look at it and then sort of take it further. What the project was about, on one hand, was energy efficiency, demand-side management, model scale building. But what we're sort of also doing is introducing concepts to students that they can use in industry or in their lives in general. Because if you're doing stuff, you need to understand concepts like return on investment, startup costs, all these things. Now, for example, we gave them 2 different efficiency motors, high and standard. One, of course, is more expensive upfront, but its lifetime cost is much lower. And by understanding that, you then make intelligent decisions in your workplace. So you don't always go with a cheap solution, but you go with a technically good, competent solution that's going to last for a long time and give you good return on your investment.
And obviously all these things have to be working models. This is not some sort of come up with a nice idea and it might work, it might not work.
No, it has to be working models. 2 weeks before the finals, we have preliminary judging, and it has to be 90% working to get into the finals. So, you know, it's cliched when you tell people whether you win or lose, you are winners for getting here. And it's so true, because for you to get to the final is a major task on its own. It means you're probably going to be, whoever's made it to the finals in CyberJunkyard 2007, I have no doubt they're going to have brilliant careers.
Now, briefly, any idea of what you might be looking at as a topic for next year? Is there any hot items on the cards?
There are a few, but I have to keep mum for a little bit, because if we don't go with that, I don't want to get people too excited on something that doesn't really happen.
You mean some engineers sitting there already with pen and paper, jotting down notes?
No, it's probably in the next month. What we're doing is we're running an internal competition in Siemens. I personally have a coffee making machine that I'd like to get implemented, because personally I'd like my coffee to come to me. I mean, people can
Well, you know what they say about engineers? Normal people say if it's not broken, don't fix it.
Yeah,
and engineers say if it's not broken, it doesn't have enough features.
Of course.
Yeah.
And I think, you know what, maybe engineers are a little lazy and we like to do things to make our lives a little easier.
Brilliant. I'm going to leave it at that. Thank you so much for coming into the studio. And
Thank you very much.
Take it work. Okay.
Welcome back. It's time now to focus on the environment. When one thinks of Siemens, it's telecommunications products that come to mind rather than highly technical products used in engineering. In fact, the business is multifaceted, and in an effort not only to raise awareness of its brand, but also to encourage interest in the engineering sector, Siemens has become involved in CyberJunkyard. Since its inception 5 years ago, the competition has grown in stature and status to the point where it is now a viable exportable event. With this year's highly topical focus on energy saving, the likes of Eskom may snap up innovative ideas as well as tomorrow's top engineers.
Increasingly popular among engineering students and lecturers at tertiary institutions across the southern African continent, interest in the Siemens CyberJunkyard competition is high. Equipment worth thousands of rands is on offer to participating teams, as well as exposure to practical, real-world applications.
It came about 5 years ago, I think it's the 5th year that we're actually running this competition, is that how do we get students that can have real-life experiences in terms of developing projects? And we basically then came up with the CyberJunkyard competition. Now, how it really came about, I think there was a program in the UK which was called the Junkyard, and what happened is team building events, people got thrown into the junkyard and had to make a car or a motorbike or something like that. And we said, well, okay, we'd like to have a similar scenario. We'd like to have a basket of products that we give across to students, give them a synopsis in terms of what their project should do, and measure what they sort of come up in terms of the innovation and the projects that are presented on today. So effectively said, okay, we'd like the junkyard aspect, but we then brought the cyber into it, given that it's digital programming, computers, industrial computers, digital networks, and hence the name CyberJunkyard was actually born.
The brief was to build a simple fluidic pumping application. What we're trying to teach them here is to be able to control in more than one way. Because in a plant, you can control direct online, which is with a simmer code or soft starter, and then with a VSD, or to use valve control. And we gave them all the options, and it's a case of this is sort of going to be more a teaching rack, because there's different ways of doing things in industry, and this one model sort of shows those different ways.
I think we all know in South Africa today that we have a serious problem with regards to the usage of electricity, and there's a big drive by the Department of Energy and also Eskom in that, in terms of looking at more efficient ways of doing something. So we thought that it was fairly topical of the South African market that the students develop a project that focused on efficiency and efficiency industrial plant applications.
The pilot plants constructed by the students needed to demonstrate energy-efficient process automation in a simple fluid pumping application. Energy saving, motor efficiency, and process automation were some of the key aspects the designs needed to display.
When we were coming up with the concept, we actually ran a competition, and one of our criteria was it must be relevant to industry right now. And right now, energy efficiency is key.
We see on a continuous daily basis Eskom advertising the fact that we should be switching our geysers off at night to save electricity. So effectively, if you look at the industrial applications, they chew up a huge amount of electricity around the country. I think if I've seen European stats, about 60% of the usage of electricity often goes into your industrial plant type of environments. So the focus on efficiency in all areas of a plant is hugely topical, and really a focus where Eskom and the Department of Trade and of Energy are actually assisting companies on upgrading old portions of their plant to get onto more modern day efficient technology.
Using technology, how can we save energy based on a simple pumping application? And that was one of the main criteria for the pump, was to calculate the cost and energy savings based on different configurations. Energy is becoming expensive in relative terms for Africa, of course. And yeah, we're always looking for ways to save. The power shortage is definitely a problem, and big industry is looking at ways in which we can save money.
Thousands of rands of equipment was provided by Siemens for the students to use in the construction of their innovations.
The products that were used in this year's competition were PLCs, programmable logic controllers, operator panels, variable speed drives, Profibus DP, I/O and network equipment, industrial computers, PCs, and a range of software in WinCC Flexible that's used to visualize the plant or the plant application that they had to build.
The PLC is a programmable logic controller. It's a small type of computer that can control a variety of inputs, outputs, analog values, typically used in small machines, applications like conveyor belts, right up to full production lines like a Coca-Cola bottling plant. A single PLC or a multiple group of PLCs can be networked together to control such a varying process. The CyberJunkyard student competition, we try to bring in a variety of products for the students to work with that they would typically find in a production plant. Whether they're going into a chemical process plant or a manufacturing line, they will see things like PLC controllers, they will see human-machine interfaces, which is the touch panel that humans interact with while the plant's running. They will see motors, and those are controlled by drives. They will see process instrumentation, measuring flow, pressure, level. They will see the various networking technologies that link them all together, bring the data to the PLC, take the data back from the PLC, and so on. So we've given them a wide variety of equipment to expose them to as many industry products as possible.
Environmental issues are debated both locally and internationally on a daily basis. With the construction of energy-efficient plants, several environmental concerns may be diminished.
Maybe a high-efficiency motor might cost slightly more than a standard efficiency motor, but in the long run, you're actually utilizing less energy and you're saving money also. And utilizing less energy reduces our greenhouse gases. And in industry, the whole world is being controlled by PLCs, pumps, motors, and your end user is using way less power than in industry.
What we're trying to tell students is that efficiency is a big focus, and absolutely these are fairly simplistic applications that we're looking at over here, but what we're trying to do is develop the basic fundamental in their thinking process so that they will continuously, in plant designs in the future, look at approaching an efficient or a better sort of environment.
Energy efficiency is a key point with regards to the rest of Africa. The CyberJunkyard competition has attracted different contestants from various parts of the continent who are putting energy efficiency into practice.
For the first year or the second year, we've actually spread it further than the borders of South Africa. This year we had Namibia involved, and we had invited Botswana. Unfortunately, they couldn't put a team together, Zambia, and also Zimbabwe. And of the projects that you see there tonight, two of the delivered projects were done from the Namibian environment and also the Zimbabwean environment, and very good projects.
In South Africa, we have a problem with energy efficiency. There are many big industries and plants out there, and if we could come up with a simple solution that could be implemented in the so-called plants, it will be beneficial to all parties involved.
The average age of an instrumentation artisan is 53. This is evidence that engineering as a career is not a core focus for the youth of South Africa. The Siemens CyberJunkyard serves as a platform to encourage the youth to get involved in the engineering industry.